Welcome to Walk About the Galaxy, the sea level astronomy podcast, where the science is universal, the opinions are personal, and the hosts are ready for prime time, or at least a late night talk show.
Yeah.
Sure. Yeah.
Right?
I would accept such an invitation.
Okay.
We could be
We could be the three-headed Kerberos version of Neil deGrasse Tyson.
Mm-hmm.
Yeah.
Instead, for the moment, or in addition for the moment,
in addition.
we are Strange Charming Top, the astroquarks, also known as Josh Caldwell,
Addie Dove,
And Jim Cooney.
coming to you from the Satellite Walkabout Studio near the University of Central Florida. Remember to check out our website to see how to get our snazzy shirts and subscribe to us on all platforms. Our stumpers today are financial.
I have so many of those in real life.
Financial stumpers are
It's not fair.
Yeah.
This isn't fun.
As we discussed on our last episode, Blue Origin is auctioning off a seat, the first sort of external passengers, not an external seat, but the first, that would be it.
They are doing external payloads.
They are doing external payloads, but not occupied as far as I know. They're auctioning off the first seat that will go to somebody outside their company or whomever. There's going to be more than one person on this first flight, is what I'm trying to say, but only one of them is up for auction.
Yes.
And the others, who knows?
Probably they're astronauts.
Probably they're people they're choosing.
You think Bezos is going to be one of them?
I don't know.
Yeah, I've been wondering about that.
I don't know. I kind of think not.
I kind of agree.
Why not? If I were him, I would do it. I mean, isn't that like his whole passion, the whole reason he did this whole thing?
I'm sure he will go for a ride at some point, but I don't know.
Go for a ride.
Maybe he realizes the first one of these things is not the one to go on.
But it'll be
Well,
the
it's
third
not the
flight of that
first one. It's like the
capsule,
15th one.
Right.
Yeah.
So,
Third flight of that capsule. And
all the capsules have done, they were,
The
batting
boosters.
100 and all that. In any event, the question for you is, I'm sure that you have each put your bids in for that auction.
You bet.
We're now going to imagine a slightly different scenario where, it's not really a scenario. The question is basically just, how much would you be willing to pay for a seat on that flight this summer, July 20th, 2021? It's car salesman showroom rules. What will it take, Addie Dove, to get you in that rocket seat? How much money can I get out of you to go for a ride on that rocket?
I don't have that much money. That's the problem.
We're going to find out how much money you've got.
Ooh, getting personal.
I have been looking at doing some home equity loans, so maybe I can use it for something like this.
At what level does it become a thing where you know what?
Yeah,
I'm going for it.
Yeah, might as well just sell everything you have.
It's worth reminding, I know you know this, but I know Jim doesn't because he always forgets rocket stuff.
Mm-hmm.
But it's also worth reminding our listeners it's a 10-minute ride, launch to landing.
Pretty much total, yeah.
Yeah, with about 3 minutes of floating around above West Texas, with a nice big window looking out at West Texas
and
New Mexico.
Yeah, New Mexico. Probably a little East Texas.
And maybe Central and East Texas as well. Yeah.
How much would I actually pay of my own money?
Like imagining that, there's...
I feel like I don't have a satisfying answer to this.
A knob is being turned down, the money is, the price is going down.
When would I actually...
And at some point, you have to act or you lose the chance to get it. Where do you jump in and say, okay, that's it, I'm doing it?
$10K.
$10K? It's the same question for you, Jim.
Oh, it's negative.
Zero amount
you would
of
have to
money?
pay me a significant amount of money to go on that flight, yeah.
Really?
Yeah. It's not that I don't... the idea of it sounds awesome. The reality of it would be I would be so anxious about it that I would not be able to enjoy it.
Really?
Yeah.
No, I would totally... I wouldn't hesitate for that ride.
I guess you could think about it, too, as maybe I would say up to $25K, because I bet I'd get some cool sponsorship stuff after that. I could get some press and speaking engagements and actually pay for speaking engagements. Get paid.
Yeah, maybe.
How much are you going for, Josh?
Stump back at you.
Stump me back. I think, it's in the realm of Addie's number, I would say.
On the order of
10K.
I think
10 to 20.
I think
10 to the 4.
Yeah. Yes, if we're using astronomical rules. I think at 10K, I think. Probably not a whole heck of a lot more than that, though, I have to be honest.
Yeah.
Okay.
Like, it'd be awesome to be the first one to be on this first flight. But, like, I would just as happy to be on the 100th flight.
Well, right. The reason I said that for the date is just like, so you're not thinking, well, next year I'm getting a raise or I've got time to save money or anything like that.
Sure.
Right.
That's why it's showroom rules. You're walking out of here with a card today.
You want me to clear out my bank account?
Yeah.
I could spend. Just kidding. I'm not gonna.
You got credit cards. Got a lot of. I'm sure you have
I
credit.
have one credit card that I could max out.
Yeah. All right. Well, I'm pretty sure that the winning bid will be more than that.
Yeah. Pretty sure. Don't forget to get your. Is our bidding closed?
Yes.
By the time this airs.
Yes. Yep. Okay. Yep. We'll have the results of our own contest. We have a bidding contest on the bidding contest for a Walkabout T-shirt. We'll talk about that when it's over, after the flight probably. But today we'll talk about eruptions from the sun, special top quark trivia.
Ooh.
New ways to track neutrinos and spaghettification caught in the act. But first, this episode of Walkabout the Galaxy is brought to you by The Ecliptic. For that special night out on the town, bring your posse to downtown Seoul and party till you drop at The Ecliptic. For quiet and intimate gatherings, you might enjoy our outer regions where the pace is leisurely, the vibe is cool, and the ices are even cooler. If the urge to dance and mingle is irresistible, just come on into the asteroid room, where we have 360 degrees of non-stop partying, including our special L4 and L5 lounges. And if you can take the heat, step into our most exclusive room, the NEO room, where the drinks are all top shelf, the beat is heart-pounding, and the heat is on. We may look like a disc from afar, but come check out the Ecliptic at Seoul and discover our hidden dimensions. The Ecliptic, where everyone knows your name.
Cheers.
Yeah. Well, it was that or Heinz means beans, or something like that. So, just like.
Sounds like a cool spot. I'd hang out there.
I like the Ecliptic.
Hang out at the Ecliptic?
Yeah. I enjoy hanging out at the Ecliptic.
Yeah. I'd probably go for those outer cooler, low energy.
You would go out in the cool.
It'd be super fun to make that whole thing. Just made me think of how awesome a nightclub bar kind of thing you could make with like different themed rooms.
Yeah.
Right.
Yeah. An astronomy solar system themed bar.
You know what you could call it?
Would be awesome.
The Ecliptic.
The Ecliptic.
Yeah.
All right. Sounds like we got our $1 million idea, guys.
This will be
is.
next to my
brewery.
And
then Addie and I can buy tickets on the flight.
Yeah. You could have such fun rooms.
I guess it gets its name from eclipses. The ecliptic is the plane.
The same root, or it's actually named after eclipses. It's
well,
probably the same root word, right?
It's got to be, right? So, I mean, in French, we will eclipse ourselves means we're getting out of here.
Really?
Yeah.
From the late Middle English and from the Latin from Greek, ecliptos or eclipti, I can't ever say those words, mean fail to appear.
Oh.
So eclipse.
So if we're gonna eclipse ourselves, it's like we're gone. Yeah. Vamos. But it's when there's a lunar eclipse coming up in a few days,
right.
Largely not really visible from North America.
Where is it visible?
In the Pacific Ocean.
Well, we have listeners all over the world, so
probably
be aware.
We don't have a huge number in the Pacific Ocean based on my latest review of our listenership. In any event,
maybe they don't track well because, like, if you're on a ship in the Pacific, it's not going to register as that's your download location.
Maybe there's not a lot of cruise ship activity at the present time, though. Eclipses when, for example, moon passes in front of the sun, Earth passes in front of the sun from the perspective of the moon, and is the plane roughly not a perfect plane. That's why it has hidden dimensions of the everything in the solar system pretty much is orbiting.
So this is something I don't know the answer to, but there are multiple definitions of the ecliptic kind of that are related to one another, but is it the plane of the Earth's orbit around the sun, or the plane of main plane of the solar system?
No, it's the Earth's orbital plane.
Okay.
Yeah, thank you for that clarification, because the other plane is sometimes called, there's an invariable plane, which is the sort of more average. The Earth has got its own plane, and the other planets are all slightly different from that.
Right.
And since the Earth is not the dominant planet, it's not the one that's really sort of determining the average plane. But they're all pretty close.
They are.
Yeah. Speaking of contests to go in space, did you see this about the Discovery Channel?
Yes, because you posted it earlier.
They are talking about doing a reality show.
Is this like Mars One, but real?
It's like Mars One, but certainly more likely to be real.
And smaller in scope.
Yes, so instead of a reality show that's sort of about a whole bunch of people going to Mars and living and dying there, where there's no infrastructure for anybody to go to Mars at all at the moment, this is about the winner gets an 8-day trip to the International Space Station.
Sign me up. I'd be on that reality show.
Well, you can sign up.
All right, I'm going to do it right now.
Do it.
So applications are open. You can do something to sign up for it. If you get selected for the show, you might have to take a leave of absence from work, because I imagine you had to do all sorts of stuff.
Oh, no. I can teach from the show.
Yeah, I don't know. Who knows what they might have you do? They might send you to some deserted island somewhere or something with no Wi-Fi. Possible.
You could go to like the Mars Desert Research Station or something.
What I found yes, we know we can send people to the International Space Station. That's been permanently occupied for decades now, we can say.
Yeah.
And private,
non-professional
astronauts have gone there.
Yes.
And we have private rockets that are making that trip and able to take people there.
Mm-hmm.
It's still a little bit speculative, this show, because they don't actually have a commitment from NASA that, whoever wins your reality show, Discovery Channel, we will allow them to come to the space station.
You'd think that would be the fundamental thing they should get before launching the show.
Well, they're going to have to work that out for their contestants, I'm sure, to get on the show. They're probably going to figure something out there. But the other thing I thought was sort of funny about it is, it used to be that the big prize you win on a show is like $1 million.
Who Wants to Be a Millionaire?
Exactly.
Similar title than Who Wants to
Be an Astronaut? Right. But it costs a hell of a lot more than $1 million to get a ride to the International Space Station.
Right.
Mm-hmm.
So I'm sort of like, what's up with that? And here's a follow-on stumper for you. And I guess we know Jim's answer already. But would you rather have $1 million or a week on the space station?
Jim
or
$1 million.
The more reasonable question is really, would you rather have $20 million?
Yeah. Would you rather have the equivalent?
Station? Right. Because it's like $20 million what it cost.
Yeah. Jim says the money.
I say the money. Oh, yeah. But I don't know. I have to mull it over. I mean,
you don't get to. It's a stumper.
That's right. You don't get to mull it over.
But I'll take the money.
What about you, Josh?
I think I would take the money.
I think I would go to the space station.
Yeah. Even though I don't need the money, so it's a very stupid thing to do. But there's all sorts of things you could do, interesting things to do with the money, and
including buy a flight on Blue Origin.
And I'd probably go more than once on Blue Origin.
Yeah,
with that.
You could be a frequent flyer.
I could take my family.
You could take your whole family.
Yeah.
Rent out the whole
capsule.
Book the
whole capsule.
Yes.
I booked the entire flight.
Oh my god, that'd be amazing.
That would be fun. Okay.
Can I reserve a spot on your booked flight?
Probably, because I have a small family.
Perfect.
So there's room there.
Perfect.
There's
a lot of details they want about me that I'm not maybe comfortable with.
I took a look at that, and there was a fairly lengthy thing to sign up for the auction. Oh, you're looking at the Who Wants to Be an Astronaut form? Yeah.
Describe your current living situation, i.e. who do you live with? Describe your personality.
Oh, yeah.
What is something people would never know just by looking at you?
The thing is, you're auditioning for a TV show.
I know, I'm auditioning by filling out this form.
You're not applying to be an astronaut. You're auditioning for a TV show.
That hasn't worked out. So.
And they're picking people, just like all these sort of talent shows, they're casting that show. They're not actually necessarily looking for...
Do you have any special talents we should know about?
Yeah, this is...
Podcasting.
I get really excited. The first season of Survivor actually sent in a video.
Did you?
Which I don't know if that video existed.
Would you do Naked and Afraid?
Yeah, I'd do it.
I know somebody who applied for Naked and Afraid, did the whole video thing, and he got through a certain number of rounds. And he seemed like the kind of person you would see on that show.
I feel like I want to guess who this is, but
it's not anybody you know.
Oh, okay.
Yeah. Anyway,
all right.
What is this show about?
Astronomy.
This episode of Walkabout is
astronomy.
What shows would you be on?
Right.
So solar somethings.
Yes.
Annie, tell us about those.
There's a new solar
Do
probe.
we have any other space news updates other than things we were just talking about? I feel like there was maybe something.
No.
Oh, okay. There was a non-Starlink.
Nice try to stall.
There was a non-Starlink launch today. I was excited.
That's right. Atlas 5 went up.
It was a Space Force satellite.
So it's sort of this. Our first topic is sort of space newsy because it's about the joint NASA-ESA solar probe mission.
Yeah, it's called Solar Orbiter, and Solar Orbiter launched about a year ago.
Right.
And it's an ESA mission joint with NASA. And this is the one that is in a more polar orbit. So it's 90 degrees to the ecliptic.
There you go.
And it's also getting super close to the sun. So both Parker Solar Probe, which is the NASA mission,
which is sort of in the ecliptic,
and Solar Orbiter are getting like way closer to the sun than we've ever gotten before. And Solar Orbit hasn't started its main primary mission yet. It'll start it later this year. But as it's been taking images, it got its first set of images of a coronal mass ejection, or a CME.
So what is a coronal mass ejection?
CME is basically a big mass ejection from the sun.
Okay.
Specifically the coronal part of the sun. Yeah.
Interesting.
So it's basically like when you see images of the sun and it's a nice disk, and then sometimes you see images where there's like a big loop and like material flying off. And that's sort of a typical coronal mass ejection. So it's where you have a lot of the sun's sort of outer layers that usually had some sort of instability, and they get flown out into space.
Yeah.
And they're danger.
The corona is the part that we were able to see during the total solar eclipse. When that disk is perfectly blocked by the moon, and you see these outer glowing stuff, which is super hot gas. It's millions of Kelvin, much hotter than what we perceive as the surface of the sun, which is only thousands of Kelvin. And one of the things these spacecraft are trying to understand is what's the heating process to get, the sun is very, very hot in the interior, cooler, then light gets out, and then after that, all of a sudden it's hot again.
Crazy hot.
But very low density.
Yeah, it's like different, and it's a different. We were talking about like thermal hot versus kinetic hot at one point.
And this is
one of these like more kinetic hots.
Yeah, this is magnets.
Yeah,
magnets.
To do with magnets.
It's a bunch of bar magnets up there messing things up.
Bar magnets at different points on the surface.
So that stuff that we see in those flares, these loops, that's glowing gas, plasma, superheated plasma that is accelerated on these magnetic field lines, and that produces emission, and so you see it as these bright things frequently in shorter wavelengths than we can see, but also in the visible. Yeah,
so typically the loops have to do with where the magnetic field lines are connecting,
right?
But then you get this burst and just some disconnection, and it all comes out. And these are really interesting because they relate to like how the sun is losing mass and losing energy, and like we said, we just don't understand a lot of these coronal layers. But it's also interesting because all this stuff then goes out into space.
Right.
So there's entire space weather offices here on the ground on Earth that's like, okay, where's this thing going? Is it coming toward us? Is it going out a different direction in space? Right. Fortunately,
so
Earth is only one.
It's not a big spherical blob going out. It's a blob going in a particular direction.
Yeah, but sometimes that direction then intersects with the Earth, and that can cause things like aurora in the nice case, but like disruptions to technology in the worst cases.
Yeah.
So these new missions. I mean, I guess there's no big groundbreaking discoveries
not a science
yet.
Discovery yet.
But this is just our first views of these things with these new things, and so I guess with some analysis and so forth, we'll learn more about it.
Yep. So this was just like it happened to catch it when it was doing some of its turning on its instruments and calibrating and looking for different things, and it saw it with the Solar Orbiter Heliospheric Imager, so imaging the area around the sun, and then it also saw it, and then a couple of a spacecraft called Stereo, which is a NASA spacecraft that's been orbiting for a long time. We have Stereo A and B, cleverly named. Also saw it. So, and it's cool because we have these spacecraft in different places in solar orbit. So like sometimes they detect the same thing, but at different times. And the solar, when things come out from the sun, it's actually spinning.
Right.
So they sort of go in these big loops, spiral
Plus,
loops.
the sun rotates fairly slowly. It's about 4 weeks or so to rotate. So if we were just looking from our vantage point here on the Earth, all kinds of crazy things could be happening on the other side of the sun.
Yeah.
We wouldn't necessarily know about it until much later, if at all. Yeah. And so having that sort of constellation of spacecraft observing the sun is important.
Yeah, it's pretty cool. It also makes some pretty mesmerizing movies.
Oh yeah, yeah. And actually, one of the interesting planetary serendipities of these solar missions is that because they're looking close to the sun, but they're frequently blocking the main disk of the sun. So they're the best, with our big fancy telescopes to look at comets and stuff like that. We can't point those anywhere close to the sun. Totally fry all the
Turns out when you're
instruments.
looking through dim things, pointing at the sun
it's not a good
bad
idea.
for your eyes, also bad for your telescope.
Right.
Similar reasons.
So they actually have been things that discover comets that are called sun-grazing comets and comets that plunge into the sun, which are these, ice chunks that we may not see at all until their final sort of death pass by the sun, which then tells you, it's like, oh, that tells you all sorts about what's going on in the outer solar system. So there's all kinds of fun stuff we can learn from those. Yeah. Well, you know what else comes from the sun besides coronal mass ejections?
Light.
And?
More plasma.
And?
Neutrinos.
Neutrinos.
Very exciting. All right, so we have today, after the trivia, we're going to talk a little bit about neutrino detectors.
Ooh.
And so today's trivia is neutrino related.
Okay.
So there are 3 independent questions.
Oh, gosh.
One historical, one scientific, and one entertainment.
Nice. Now, is each question multi-part?
No.
Oh.
No.
Okay.
No, those are the multi-parts.
Okay.
So, your first one, the historical one, is who did first propose the existence of neutrinos?
Okay.
You kind of
know
it or you don't.
Is this just an answer question, or are we waiting to answer all of them?
Is it free response, or are you going to do a multiple choice on that?
There will be multiple choice for the last part, but not for this.
Are we answering any of them now, or waiting for all of them?
No, you can wait.
Okay, but we get all of them now?
You get all of them now.
Oh,
okay, good. All right.
It's not like
so yeah, who first proposed the idea of
Mr. Neutrino?
Neutrino.
That's what his friends called him.
Mr. Neutrino.
The second one is
that's Mr. Neutrino to you.
Slightly involved. No, not that involved. So I'm afraid of neutrinos my own self.
Really? You're afraid of a lot of things we're
should
discovering.
I'm not actually afraid of neutrinos. But neutrinos are freaky because currently, right now, there are gazillions of neutrinos just flying through your body. What
Is that a British gazillion or an American gazillion?
Yes.
So I decided earlier that I didn't like the fact that I was being violated by neutrinos continuously, and so that I would build myself a neutrino suit.
Like a Faraday cage?
Yeah, I'm going to build myself a neutrino suit. But it's simple. Like, I mean, it's going to be similar to X-rays or something like that, are very bad for you. And so what do you do when you go to get an X-ray? You put lead on, right, to cover your goodies and stuff like that when you're getting your arm.
Yes. Only if I've just come from the goodie store.
Because they absorb X-rays, but they also absorb neutrinos if you have enough of it. And so I was thinking, how big would my neutrino suit have to be? And so your question is going to be,
jeez,
like how thick?
Not how thick. Your question is, what is the mass of my neutrino suit going to be?
Oh.
It's got to protect me from at least half the neutrinos coming at me.
I don't get it.
Okay, in our current environment here on the surface of the Earth.
Our current environment right here.
With the sun as our primary source, right? Of
I would like to,
here.
right.
And you want to cut the flux of neutrinos that are passing through your body in half.
I want to cut that in half.
How much mass do you need to put between you and the sun?
How much is the mass of my suit going to be? Now,
I
I will give you some choices for this.
Yeah, that one you'll give us multiple choice.
I'll give you multiple choice on this and the last one. I'll save the last bit for
later.
For later.
Right.
Is it the mass? So close to it, within an order of magnitude or so. The mass of the moon, the mass of the Earth, the mass of the sun, the mass of the galaxy, or the mass of the observable universe.
Okay. It's kind of amazing that it's within an order of magnitude of one of those five things.
It is.
Those are pretty far apart.
It is.
Yeah. Okay, cool.
All right.
So
mulling.
It's neutrino themed because we have sort of a new technological breakthrough that's related to your question, because since they pass through things so happily and carefree, it's hard to measure them or detect them.
Really tough. And so what we end up doing is making these, our neutrino detector is basically just a huge vat of some kind of fluid that we hope a very small percentage of the neutrinos that pass through there will actually interact in some way.
Yeah.
The trouble is with neutrinos is, as the name suggests, and we've talked about before, they're neutral, electrically neutral, which means they don't interact via the electromagnetic force. They're also very, very low mass, so they don't interact very much via the gravitational force, not that that would help you that much. They interact via the weak nuclear force, but as the name suggests, that's a weak force and doesn't happen all the time. So you have to have a lot of neutrinos passing through a huge vat of something in order for occasionally one of those neutrinos to interact, which means that neutrino detectors are going to be better if they're bigger.
Yes, bigger is always better.
The trouble with,
in this case.
Yeah, the trouble with bigger detectors is then you need more detectors, more detection, right? So basically these things are huge tubs filled with tons and tons and tons of fluid, but that means you kind of have to line the whole exterior with detectors of some kind. And so this turns out to be an engineering challenge, right? To build a neutrino detector that is that can scale up to these huge sizes.
Do you know what engineers love?
What do they love?
A challenge.
They do love a challenge. And engineers at the Lawrence Berkeley National Laboratory have been up to that challenge and have designed a kind of detector now that is going to help us build these. The detector is not for, that they're designing is not for neutrinos specifically, it's for the byproducts of when a neutrino hits something in that big vat of things, but
ultimately it's an electron detector.
Right.
It's detecting electrons that are knocked off by neutrinos.
Right.
You put them frequently in these caves, so that the only thing that possibly could be getting in there to knock an electron off is a neutrino.
Right.
Because nothing else can get in there to do anything.
You put it under, and so one of the things that they're going to use this for is this project called DUNE.
Ooh,
What does that stand for? The Deep
DU
Underground
Neutrino
Experiment. Where
it's deep underground.
It's deep underground. But it's actually cool. It's like two neutrino detectors. One is very near Fermilab, which is in Illinois, and they're going to have a neutrino production thing.
Right. So they're not going to be they're going to be sending a beam of neutrinos rather than just like opening it to the universe.
Right. So the DUNE isn't trying to detect. Well, it's going to be trying to detect all kinds of neutrinos, but one of the experiments it's specifically going to do is it's going to have the neutrino detector right next to the source of the neutrinos, and then another one 800 miles away,
South Dakota.
In South Dakota, what
deep underground.
My favorite thing about the neutrino, about this story, is that it's 800 miles away, and it's like, oh, how do we have to clear a path to let the neutrinos get from the source? Doesn't matter.
Doesn't matter.
Yeah.
You don't have to do anything.
Yeah.
There's no big tunnel.
That's right. If you have your neutrino detector, you want to get it to your friends who happen to be on the other side of the world, just point it down.
Yep.
And they get there.
Yeah, it's pretty awesome. It is a giant pain. They have to dig out, they have to build this thing deep underground. It's like more than a kilometer underground, the secondary detector there. So you have to dig out a lot of rock and do a lot of stuff. But these new kinds of detection stuff is really going to help. And I think this stuff is going to come online in the middle of 2020s.
Well,
they're testing it now.
Yeah, it sort of passed an initial test.
Right.
Did I say passed it?
I think you did.
I think I did too.
Yeah.
It passed an initial test, and one of the fun things about it too is that it's sort of using some kind of like basic off-the-shelf kind of components,
right?
And it sort of give us a sort of like 3D view of what's going on with what do they call them? They're sort of like voxels, or their 3D imaging is
pixels?
with three-dimensional versions of pixels.
Oh, I don't know.
For neutrinos.
Yeah.
Yeah.
LARPix.
This one's called
liquid
Larpix.
argon pixels.
There we go. Yeah.
Yeah, liquid argon is the thing that they fill these things, which is amazing because that has to be really cold.
Yeah.
And so you also have to design things that work in really cold environments and these things too.
Yeah.
And that what you said is the really cool part is that it's scalable because these things are fairly cheap and easy to produce, and so you can produce a huge numbers of them.
Right.
That work under these crazy conditions. It's going to be awesome.
Pretty sure the people that made those are just like big people that like to do LARPing, and they were like, how do we come up with an acronym?
Live action role play. When are we expecting to see the first ones? The first sort of...
Oh, I don't know. For Dune, I think that the first science is going to happen in like 2027 or something like that. But the first tests of it will be just in a few years.
Okay. Well, we'll be able to talk about that when we're on a late night talk show.
Sure. Exactly. Yeah. Maybe when I'm up on the ISS, somebody asks me a question about
There you go. Our last topic before we tackle Jim's trivia was another sort of fun stellar kind of observation. I'm trying to tie it back into the first observations of something happening at the sun, where obviously it's close-up coronal mass ejection views. This also is sort of related to things being ejected and absorbed by something somewhat related to a star.
A black hole.
In this case, a supermassive black hole.
A star was torn apart.
Right.
Yes.
Yes.
It lost all of its mass.
Yes. So half in and half out.
Yeah.
Through the famous process of
spaghettification.
Yes.
Spaghettification. Now I'm hungry.
Right.
The pasta dinner tonight.
Which is when the gravity on the sort of the near side of something is so much stronger than on the far side, things get stretched out.
Right.
Yeah.
And
it's awesome. It's the same thing that causes tides on Earth, and it doesn't seem like that would be connected at all, but it's the same.
Much
totally
different
same
scale.
Yeah.
Fortunately.
But yeah, so what that means is this is something even Newton would, Newton didn't have any idea about general relativity, all these very complicated time dilation, crazy things. But he would have predicted that something falling into a black hole would become spaghettified, would stretch out.
If you give them the mass and the size or the distance between it.
Yep.
And I was thinking, there's actually examples that we've seen sort of spaghettification right here in our solar system. Do you know which one I'm talking about?
Like Shoemaker Levy?
Exactly.
Yeah, that's what I was thinking.
Yeah. Shoemaker Levy 9.
Yeah.
Or the comets, the sun-grazing comets that we sometimes catch with the solar telescopes.
Exactly, yeah. So Shoemaker Levy 9 was a comet that was discovered after it had been spaghettified.
Yeah.
And it was broken apart into a string of pearls.
Yes.
Sort of
less delicious.
A couple of dozen or more little chunks of ice
pearls, maybe.
that were all sort of following the same orbit. As it came too close to Jupiter, and Jupiter's gravity stretched it out, and it was too much stretching for the tensile strength of that comet to withstand.
Right.
So what do we see here?
So I guess that same thing happened to a star that came too close to one of these supermassive black holes that lives at the center of a galaxy. This is not our supermassive black hole. This is something 200 million light years away, which in the grand scheme of things is not that universal. Yeah, it's not that far. So this is one of the closest. So anyway, they were able to catch this event as it was happening. Now, obviously, when we say catch this, you're not seeing. You're not
see
seeing
the star.
Detailed pictures of this. We don't have the resolution for that, but we're able to see the change in the brightness of that region over time in various wavelengths, and be able to kind of watch this star get eaten as it got eaten. So, it's nothing groundbreaking. Nothing has radically changed our view of the universe or anything like this. But it's cool that kind of the star did exactly what we thought it would do.
Well, it's a little bit of serendipity because some of the material goes into the black hole, but that releases a lot of energy, which outside the event horizon, which causes some of the rest of the star to be sort of vaporized and expelled from the region, which
something like half the mass or something gets blown out, and these jets and things like that away from that.
And that presents a sort of an optical screen that you can't see through, so you don't actually see. So once that is gone, you can't see the rest of whatever is happening with the gobbling up. So
so you got to catch it early before that stuff gets in the way, and they did, and they got to see all this fun stuff happening. So
cool. Speaking of early, I believe the first part of your trivia was historical.
It was. All right, my friends, you all know the name.
I have a guess.
Give you that.
And if I'm right, I knew it all along.
Great.
Very good. So, who first proposed the... This was... Well, I'll tell you the date after you tell me the person.
Okay.
Who first proposed the existence of neutrinos?
You have a guess. Go ahead.
I'm going to say Paul Dirac.
Paul Dirac.
Oh,
Okay.
That's pretty good.
Addie?
Einstein.
Einstein. Both excellent guesses. Both of those folks were heavily involved in the early days of quantum physics and all these kind of things. The actual answer is Wolfgang Pauli.
Oh, yeah.
Did I say? What did I say?
Close.
Isn't that what I said?
I think, yeah, if there was some uncertainty.
Dirac was involved.
I said Paul. Didn't I say Paul?
You did.
I said Paul. I knew Paul was in there somewhere.
You did. This was back in 1930, and he proposed it as kind of... It was known that in beta decays, this is when a nuclear or the nucleus of an atom decays and changes. In order to conserve energy and momentum in that thing, you actually needed a little bit more
Something
than the things that they could actually see.
Okay.
And so he proposed it as a solution to that. It was found, a couple decades later in the 1950s. It was kind of definitively discovered, and they got a Nobel Prize for that.
Nice.
All right. So I want to make my suit. I'm terrified of neutrinos.
Oh, right.
They're just tearing through me at all the time. What is the mass of the neutrino suit that I need?
Moon, Earth, Sun, Galaxy, Universe.
Galaxy, Universe.
I went first last time, Addie, so you have to go first this time.
I like the moon, so I'm going to guess moon.
You do like the moon.
You do like the moon. I think my reasoning is that it's definitely more mass than the sun.
Okay.
Because the neutrinos are coming from the interior of the sun in the first place.
Okay.
So I don't know. I'll go with the Milky Way.
The Milky Way. Well, neither of you got the correct answer here. It's actually the mass of the observable universe.
Oh, no. That seems like an impractical suit.
It's an impractical suit.
I was hesitating, and
that's heavy.
It turns out that if you want to stop about half of the neutrinos, you need a sheet of lead. This is for typical average energy neutrinos. You need a thickness of lead that's about 1 light year.
Right.
1 light year's worth of lead to stop, on average, half the neutrinos that go through. And then if you calculate the mass of a sphere of lead, 1 light year.
Oh, no. It's not I was just thinking
just a suit.
Just a thing like suit. This.
If I'm wearing the suit, it has to cover me.
Yeah.
All the way around. Oh, well, that's why I got it wrong. Because
you just had a wall plate, like a plate.
That's right.
Between
I was
you
just
and
like,
the sun.
yes, just like.
That's not a suit.
Just behind it, just dodging
my
behind
suit.
it.
And so that mass turns out to be about 10 to the 52 kilograms, which is not exactly the mass of the universe is probably 10 times that.
I don't think I like this
you're within.
Okay.
You don't like my cat? It's possible.
I like it.
Is there a different material you could use?
There probably is. Yeah, I mean,
liquid argon,
denser things. Osmium or something like that might do better.
That's right. Was osmium is that the densest element?
That's the densest element. Yeah. All right. So as a final last,
that's right.
Fun
There's
thing,
a third part.
There's a third part, totally unrelated. But just for those who aren't very necessarily, maybe they didn't know any of these things because they're not so scientifically inclined, but maybe you're...
we didn't know them.
Star Trek inclined. You didn't. You got them wrong anyway. This was just a random fun thing because I was just going down a rabbit hole of neutrino things.
Yes. As one does.
As one does. So, in the Star Trek The Next Generation episode, A Matter of Honor.
Oh.
Yes.
I don't know if you remember this episode or not.
If you describe it to me, I will.
In this episode, there was like a switch of officers. So Riker goes to serve.
Oh yeah.
With some Klingons and some other people come to serve on the Enterprise. Anyway, in that episode, they use a neutrino beam to kill a certain life form.
Okay.
So your question is, what were neutrinos used to kill in this episode? And again, this is very trivial. But I had fun looking at
I really
things.
don't remember that. I'm going to guess...
Hold on, you have choices.
Oh, thank goodness. Okay.
You have choices. The choices are biomimetic life forms,
okay,
subatomic bacteria,
ooh,
trinucleic fungi, xenon-based life forms,
ooh.
or megafaunal viruses.
Are these all things from Star Trek, or some of them are things you
Who
just made up?
I'm amusing myself. It's not.
Okay.
This is not actually a good trivia question. All right, go for it.
Can you say it again?
Biomimetic life forms,
Uh-huh.
subatomic bacteria,
Uh-huh.
trinucleic fungi,
Uh-huh.
xenon-based life forms, or megafaunal viruses.
I'm going with the first one.
I'm going with the second one.
Subatomic bacteria. Well,
Yeah.
Addie wins the day
Wow.
today. It is
That's why you need neutrinos.
Subatomic bacteria. I was just really hoping that nobody actually.
That
wrote
was
something
what
with
that pissed me off
bacteria.
so bad when I saw this.
We should have Mohammed on and ask him about
This
it.
is a
Subatomic bacteria.
You have to make a bacteria out of something.
What is
it turns
right,
out.
What is it made of?
Yeah.
It's made out of subatomic particles, Jim.
Very upsetting.
That is upsetting. I'm very
The
upset.
first 4 of those, by the way, were things from the Star Trek universe. I made up megafaunal viruses. These are enormous, super-sized viruses.
Yeah.
But the rest of them are things in Star Trek. But apparently, neutrino beams kill subatomic bacteria.
Good to know.
Just good to know. Keep that in the back of your mind.
Well, I'm sorry to hear that, but yeah. Well, while it may have felt like standing in line to get into Seoul's hottest nightclub, the Ecliptic, it was just another episode of Walk About the Galaxy. Write us a review and hack the scrolling electronic news sign in Times Square in Manhattan and have it scroll by there. Be sure to follow us on Facebook and Instagram to get all our updates and check. Did I say updates?
I've been doing that.
Get all our updates and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel where you can see most of our episodes, some of our bloopers, and all of our music videos. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy
and ask us questions anywhere using hashtag AskWTG. Go back and re-listen to this episode to hear the faintly distinct clicking noises of my dog's feet on the satellite studio floor.
Yes.
Our theme music was composed by Richard Jerusik. Thanks to our listeners in Washington, D.C. and around the world. Stay safe. I'm Owen Wilson.
I'm Addie Dove.
And I'm Jim Cooney.
We're the astroquarks, signing off until the next episode of Walk About the Galaxy.
I didn't have an actor prepared today. Neutrinos! That's not what I should have yelled.